Hey guys, welcome to graphing y equals a cotangent of b of x, bx, excuse me. So we've already talked about the tangent function, and now we're going to talk about cotangent and graph a couple of examples for you. So I've kind of laid out a general description of things that we know about the just cotangent x function. Number one, the period is pi, okay? Two, the domain is all real numbers except multiples of pi. Okay, the range is all real numbers, and to find the asymptotes we use bx minus c equals 0 and bx minus c equals pi. Now that's different than what we used with tangent. Tangent, remember, was from negative pi over 2 to pi over 2, so that's different here for these asymptotes. The reason why we think about multiples of pi, okay, that's where sine is going to be equal to 0. Remember, cotangent is equal to the cosine x divided by sine of x. So this domain is undefined where sine of x equals 0. So that's what you got to be careful of. If sine of x or sine of theta equals 0, you're going to have a problem. You're going to have something that's undefined, and that comes at multiples of pi. And so here's the graph of cotangent. A little bit different than tangent, but notice that in between the asymptotes, halfway between, are the x-intercepts. So here's our first x-intercept. If this is pi, halfway between would be pi over 2. This point would be pi over 4. This would be 3 pi over 4. It's very hard to write those in, so I didn't. But halfway between your two asymptotes is your x-intercept. And then halfway between here, that quarter value is going to be the maximum, or not the maximum, the high point, I guess, here, or the easy point where you're going to get 1 or some integer. And then in between here, you're going to get another integer, which is easy for us to graph, so we connect it with that smooth curve. Okay, again, here are two other asymptotes, 0 and negative pi. Halfway between is the x-intercept, and then those quarter values. Okay, that's going to give us usually that nice integer that we can plot easily here. Okay, those are the quarter and three-quarter points that your textbook is talking to. So let's go ahead and look at two examples. In our first example, we're going to plot the graph y equals 3 times the cotangent of 2 of x. So just like tangent, just like sine, cosine, there's certain things I just want to find out first. Number one, the period. The period of cotangent, the period is pi, so our b value here is 2, so we're going to take pi divided by b, which is equal to pi over 2. So our period is pi over 2 in this case. Now, if we wanted 4 equal intervals, or equal intervals here, we can divide those up by 4. So pi over 2, our period, divided by 4, which is the same as multiplying by a fourth, equals an eighth. So these little tick marks here are going to be an eighth. Okay, 1/8, 2/8, 3/8, 4/8. Okay, and we'll talk about that. So those little intervals are going to be worth eighths. The amplitude is the absolute value of our a value. Our a value is 3, so our amplitude is 3. Okay, so those are where those good points are going to come in 3 and -3 that I talked about in the first part, the quarter and the three-quarter points. The other thing we got to find are the asymptotes. So I set our bx minus c value equal to 0. There is no c value, so it's just 2x equals 0 and 2x equals pi. I solve for x here. I get x equals 0 and x equals pi over 2. So once I have these four things, I can go ahead and plot my function. I'm going to start with the asymptotes. So at 0, I drew a green line. There's my 0 asymptote. Here is mine at other asymptote at pi over 2. Okay, so I go ahead and drew those in. Halfway between 0 and pi over 2 is my x-intercept. So that's going to be pi over 4. A half of pi over 4 is pi over 8. There's our interval. So this little guy is pi over 8, and we're going to go up to our max, which is 3. And then this point is 3/8, and we're going to go down to our, not our maximum, but down to our value here, our quarter point, which is -3, and I make a smooth curve. So that's one period. I'll do another one. So I go from 0 and I went over here. That would be negative pi over 2. Halfway between the asymptotes is the x-intercept, so that's negative pi over 4. Okay, and I go halfway over, or quarter of the way over, halfway in between, which is a quarter point. I go up to 3, and then to the right of that I go a quarter point, and I go down to -3 and connect it with a smooth curve. So that is my graph of y equals 3 cotangent of 2x. In the next example, we're looking at graphing y equals 1/2 cotangent of 1/4 x. So again, I look for my period, my interval, my amplitude, and my asymptotes. Those four things can help me plot this function. My period is pi divided by b. My b value is 1/4. Pi divided by 1/4 is the same as pi times 4, so my period is 4 pi. If I break that interval up into four nice equal distances, 4 pi divided by 4 is pi. So each one of my tick marks there, my major key points are worth pi. The amplitude is the absolute value of a, which is 1/2. The asymptotes are found, bx minus c equals 0, and bx minus c equals pi. There is no c value here, so c is 0. So I have 1/4 x equals 0, so x equals 0, and 1/4 x equals pi, so I get 4 pi. So I go ahead. Here's my 0 asymptote. Here's my 4 pi asymptote. Halfway between is the x-intercept, so this point here is 2 pi. So if I take a half of this, I get the quarter point, which is pi right there. So I go pi up to 1/2, put a point. Over here I go to the right. This is a quarter distance. It's halfway in between, but it's worth a quarter point. So I drop down to -1/2 and connect my graph with a smooth curve. That's one period. I'll do another one here. So I go from 0 and I go to the left, and that is going to be -4 pi. Halfway between is my x-intercept. I go another halfway in between these two, and I get my point here at 1/2. Halfway in between here, and I go down to -1/2 and connect it with a smooth curve. It's important to know that these points are pi, 2 pi, 3 pi, 4 pi. They're in that interval of pi there. So that's how you graph cotangent of y equals a cotangent of bx. If you guys have any questions or comments, let me know, and we'll see you next time.